Let's take a look at the 2017 free response question number 1. This is a calculator question, so you may use your calculator to do any and everything that the calculator can or will do for you in this problem. Let's take a look at the prompt. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank at a height h feet is given by the function a. A of h is measured in square feet. The function a is continuous and decreasing, so let me get my pencil here. The function given is continuous, that will likely be important, and the function a decreases, the area decreases as the height increases. Selected values of h are given in the table. So A of h is the area of a horizontal cross-section. We do not know what shape it is, if it's a regular or irregular shape. Letter A, use a left Riemann sum with 3 subintervals indicated by the data to approximate the volume of the tank. Make sure that you give the units of measure. So, for the left endpoint approximation, this is going to be left endpoint number 1. This is going to be left endpoint number 2. And this is going to be left endpoint number 3. And I can't write the number. Sorry about that. When I look at the heights of the rectangles, or the bases, of the rectangles, that first rectangle is going to be 2. The second base is going to be 3. And the third base is going to be 5. So these are not common bases, so we're going to have to write up our individual rectangle areas. So for letter A, I'm doing approximating the integral from 0 to 10 of A of h. That's my function, and it's dh, it's not dx. We already said that the first base was 2, the second base was 3, the third base was 5, and then we have L1, L2, and L3. You can leave this answer with the units on it if you want to, but since you have a calculator, you can go ahead and calculate that to be 176.3 cubic feet are the proper and correct units for part A. In part B, does the approximation overestimate or underestimate the volume of the tank? Explain your reasoning. So the easiest way to do that, if you don't remember whether a left or right endpoint approximation, edit undo, whether it increases or decreases or over or underestimates, is to draw a decreasing curve. So I started out by drawing a decreasing curve, as you can see here, and then I did 2 left rectangles, and I can easily see that I am overestimating the area. So if we look at my answer in part B, the approximation is an overestimate because of the volume, because A of h, or the area of the cross-section, is decreasing. And that's all you need to say to get credit for that part B. In part C, the area in square feet of the horizontal cross-section h at height h feet is modeled by the function f given by. So now we are, instead of looking at the table values, we have an actual function that predicts the area of the horizontal cross-section. Based on this model, find the volume of the tank. So now it's a calculator problem. So we approximated the the volume using a Riemann sum. Now we're going to use this function to accumulate the exact area. So I write my integral, but this time it's f of h is the name of the function, dh, and with my calculator I get 325 cubic feet, and that comes directly off the calculator. And in your resource packet, it tells you exactly how to do that. I think most of you are very proficient at using your calculator to accumulate. And then letter D, we get to our wonderful related rate question. Water is pumped into the tank. When the height is 5, so we're going to record that, h is 5, the height is increasing, so we have increasing, and then we have the word rate. So we have height rate. So that's going to be dH/dt, recorded onto the paper, you'll see below when you see my work, 0.26 feet per minute. My job, find the rate of volume. So we're finding rate, we're finding volume rate. So basically we're finding dV/dt. That the water is changing with respect to time when the height of the water is 5 feet. All right, so let's come down here. The volume of our tank, so I've recorded H is equal to 5 feet. I recorded dH/dt is 0.26 feet per minute, and I recorded that I want to find dV/dt. dV/dt is, so if you, let me uncover this for just a second. dV/dt, remember, they've already given us a rate. So when we are trying to find the volume rate, they've already given me F of H, which is the volume rate, multiplied by, when I do the chain rule, dH/dt. So this is my related rate equation. I really don't have to do anything. The derivative has already been taken for me, but by the chain rule, I do have to multiply by dH/dt. So I take the function that they gave me, the f of h function, I substitute 5, and I multiply by 0.26 to get dV/dt to be 1.694 cubic feet per minute. All right, let's take a look at the scoring rubric to see how that plays out. So notice that the first point is for the units in A, C, and D. If you left units off or you had incorrect units on either A, C, or D, you lose that point, but you only lose it one time. You don't lose it 3 times. In letter A, we get 1 point for the left Riemann sum, and I have to see your setup for the left Riemann sum. So it can't just be that the answer 176.3 appears out of nowhere. You must show your setup, and you get 1 point for the final answer. You could leave it like I underlined it, or you can just combine to get 176.3. In part B, you get 1 point for stating that there's an overestimate, and that the reason being is because A, or A of H, is decreasing. In letter C, you get 1 point for writing the integral and 1 point for correctly reporting the numerical answer. In part D, you get 1 point for showing your dV/dt, which is what I showed you on the other side, is that understanding that the derivative has already been taken with f of h, because that was a rate, and then you complete it by the chain rule with the dH/dt, and then 1 point for your numerical answer. So that's question number 1, calculator friendly 2017.